to share our experience about using product ontologies as a backbone for generative AI solutions. Who are we? We are PANTOPIX, a vendor-neutral consultancy and solution provider in the area of technical communication. Our main fields of expertise are content management, delivery, topic-based offering such as data, and creating data pipelines to move the data from source system to target system, for example, preferably using IRDS. And we use as an integration point knowledge graphs to provide a single source of truth. Who am I? I'm Max Gärber, partner and principal consultant at PANTOPIX. I have 10 years of experience in the field of product information management, and just added another 10 years of experience in the field of technical communication.
Hi.
And my
welcome everybody. Nice to see you. Maybe some of you saw me yesterday. I promised not to talk about AI. Today I'm also not going to talk about AI because that's what he's doing. That's his job. I'm just telling a little bit of stories, and he's for the more serious stuff. My name is Martin Lai. I'm also a partner at PANTOPIX. I'm doing the consultancy stuff, less from the technical point, but more from the business point of view. I have a background in linguistics, and I've been working in the field of technical communication for 25 years or more. I stopped counting. I was asked one day, do you want to have a career and you want to move from one department to another? So I was asked to go into marketing. And I said, well, yes, I prefer a career, that's right, but I don't want to go into marketing. I rather stick with TechCom. And I've been doing that for a long time, and I'm experiencing right now a period where I think, or where we also think, that it's a very, very exciting time. We have lots of new technologies, we have awareness, and we think that we can basically push technical information into the future with what we're doing right here. All right, I think that's it for the introduction. Now let's get serious. I got a couple of messages I would like you to take along. You can read them here, and of course we talk about a little bit about knowledge graphs, because we are very much convinced that this kind of methodology, that this kind of technology will help us to deliver the information to our customers in the end. So when we talk about content delivery, when we talk about how to intelligently delivering our content to the customers in the end, knowledge graph still is, maybe we should not call it the silver bullet, but it's still one of the most potential technologies that we have out there. In addition to that, we also would like you to take along that maybe some of you are already familiar with IIRDS. Yes, we've heard about that. So we think that IIRDS, in our point of view, is also some kind of an ontology that helps building knowledge graphs, but that we also identified certain gaps when we look at IIRDS, and this is where we try to connect our information to the product. Because that's where IIRDS just says, hey, I've got a docking point, and then that's it. And we're trying in our talk here to fill this gap in providing or in suggesting a product ontology. And if we combine these two ontologies, we think that we do have, as we labeled our talk, that we do have the backbone for AI-driven application. If you take that along, we're quite happy, and let's see how we go into detail here. First of all, just a little bit of a reminder of where we're actually starting and why IIRDS was developed. So one of the challenges that we're facing in TechCom is that we want to deliver technical information to a content delivery portal. This is basically what a lot of people are telling us here, and it's quite easy if you're using the same products from one vendor. So if you have a content management system from vendor A and you have the corresponding content delivery platform, pushing information from A to B is quite easy. It should work all right. However, if you have different solutions in place, it might become a little bit of a hassle. How to get your metadata, how to get your content from, let's say, content management system A into a CDP from a vendor B. So it's not as easy as one would imagine. It's not just clicking a button and the information is there. What else do we have? Well, we have a big challenge if we try to interconnect information from various information silos. If we're not just looking at a content management system, but also, let's say, at a spare parts catalog or information from a PLM system or from maybe also a SharePoint, even more tricky it is. Yeah? And in addition to that, also when it comes to connecting this information to the real world, you all have smart products, or let's say you have products that have sensors, you have operational data, and you want to connect it to your technical information as well. And then it's also quite a challenge that we're facing here. Another challenge that we're basically facing, and I think you've been wandering around this fair, and basically at every booth you say, oh, we've got a chat. We've got an LLM. Yes, I can see you nod. Yeah. That's quite obvious. So basically what we usually see, a lot of applications that will allow us to interact with a computer system in natural language. And the results, they're fairly good. Yeah? They're surprisingly good. But they're not always accurate, as you probably all realized. So this is also one of the big challenges that we are facing. We talk about this hallucination effects or the trustworthiness that the information that you're getting is maybe not as valid or as factual as you would like the information to be. Especially if you're working for a company that is selling critical products, or let's say an aircraft. You want to trust your LLM to how to maintain the fuselage or something like that. I don't think so. And also our customers tell us, it's okay what you're doing with these LLMs, but we've been doing a lot of research and we rather stick to something else. So these are some of the challenges that we're facing in TechCom. One of the challenges that has already been solved is how to deliver information into a content delivery portal. This is what we're doing with IIRDS. A lot of you are familiar with IIRDS. Those who are not familiar with it, we just go very deeply into what, not deeply into what IIRDS is doing. It provides basically a standardized set of metadata, controlled vocabulary, and also a standardized format and a structure on how we deliver information, let's say from a content management system into a content delivery portal. And the basic unit, what they're looking at is, I don't have a pen, let me use this one here. Because what IIRDS basically is doing is they have information objects. Yeah? This is just a representative of an information object. Yeah? So it says, okay, what kind of object are you? Oh, well, I'm a document. And then I can go further and say, what kind of document are you? Oh, well, I'm a owner's manual. And then I might have some applicability, so it's more for operations or more for servicing. So it basically describes this information unit in great detail. And that's what, and also some other information, we could add a metadata according to the subject or to the supply or the life cycle phase. So this is quite nice what IIRDS is doing, but it's still missing, or it fails to solve the major issue on how we can connect this to the product itself. And I was just wondering, Max, do we have any solution on how we can resolve this first challenge? On how we provide more information about the product than is given in IIRDS?
Yeah, I think so. And thanks for that example about the document, which I would like to follow on here. So this is our depiction of usage of a knowledge graph in a end-to-end solution. So going from the source system, structuring the information even further and mapping everything into the graph, depending on the domain. So if we have that example of the document, then the ontology that resides also in the graph defines the properties that are available, for example, the information type. And through this mapping, we can bring representatives of the documents, for example, in the graph to keep all the information that we want to provide to the consuming systems. And the consuming systems then use the graph to have a unified view of all of the data that resides in the graph. One detail, I don't know like how many of you have like knowledge of how a graph is structured. Anybody? 1, 2, 3, okay. I would like to explain also really shortly how this works and also why from our experience and perspective this serves really well as an integration point with language models. So taken like an almost random text from the internet, which
Almost.
yeah, I took one that is like this is pre-internet times. This is an old nursery rhyme I just found, but it has a lot of information in it, and we can encode this information in the graph, and that works for almost any text that you would have. Technical text, text from the humanities, it works for everything. So here we have in the first sentence, we have King Cole, who obviously is a merry old soul. And in the graph, we have, do we see the pointer? No, okay. In the graph, we have the king as an entity, which has a relation, or in this sense, he has a property, which is merry. Or he has an item, which is a bowl, so we can preserve all that information in a structured way, and it is completely open and flexible. So whenever new information comes in, the graph is able to hold it. And another good thing is that we can navigate the graph. So if I would ask a question about a certain fact, I would get that fact, but I can also navigate further to related information. And the best thing probably, if we talk about integration with the language models, is that the way these statements are put in the graph are in the form that is quite close to natural language already. So we always have subject, predicate, object. Every type of fact that we have in the graph is in that form. And that goes very, very well together with language models. So if we have this information in the context, then that is already quite usable. All right. Little detour of the inner workings of the graph. Let's look at another aspect of the knowledge graph. As Martin just said, we have form and we have content, and the knowledge graph should always contain those 3 layers. So we would have the layer of the ontology, which is more or less the data schema, so which properties are even allowed. Do we have an information type for a document or not? Then we have the taxonomies, they build on these. And last but not least, we have the information layer, which contains all the instances that we want to keep in the graph. So for the ontologies, we are talking about tens. Maybe you will have 50 or 60 classes. Taxonomies, we are talking about the hundreds. And like the instance data, we are talking about thousands to millions of entries. Yeah, the example for IRDS, as we just said, ontology defines, for example, the document type or the information subject, and thesaurus then would give you certain instances of these concepts. For example, information type is operation manual or service manual or FAQ that lies in the taxonomy or thesaurus layer. And the information or instance layer would then contain information about all the documents that you would have processed with all their metadata, and yeah, maybe with relations to each other or other entities in your graph, such as products, for example. But RDS does not give a lot of structure for keeping information about products, so there was something to do for us. There's something that Martin will talk about.
There was something that I'm going to talk about, because we strongly believe that there is actually this necessity for a product ontology, or for, as we going to see on the next slide, basically a set of different ontologies that relate in one way or the other to the product. So just keep in mind, once again, IIRDS and it does that. One could argue about IIRDS. There are always some people who say, oh, I don't like this, the way they modeled it, or I sometimes feel a little bit of clumsy how they did develop the standard, but still it's out there. And why not use it? We are also founder of the members of the IIRDS consortium. We also participate in developing the standard. Of course, it's a common work, and we do not always agree of what has been developed, the way it's been developed, but we still want to use it because we think we should use it because it is a standard. And why not use standards if they're already out there? So whenever it comes to modeling the information world, we would always go with IIRDS. But then, of course, we have this docking point that I mentioned before, and of course, our product or our technical information always relates in one way or the other to a product or a component. And if I just have a question as how do I replace the front door of my oven, a lot of questions apparently arise. In which market am I? Which product am I referring to? Which door is it? Do I have different variants of a door? So these are all information that we, one way or the other, need to encode in our knowledge model. And that's why we suggest to expand IIRDS and use this class. It's called product or product variant, and we try to expand that and use it as a docking point to plug in our own product ontology. Now I just have to take a little bit a look at the watch, how long we are allowed to talk here. So that depends then strongly on how deep I'm going into our product ontology. So we could talk about this now for 45 minutes or 4 days. So let me just try to give you an overview of how we conceive this domain model of the product. Basically, what you can see here, the colored versions are different types of ontology that we've developed. One, and this is the primary ontology that I'm going to focus on right now, is the product hierarchy. And then we have the market segment that deals with the country information, property values, and also, we could just call it entity here, and you might wonder what kind of a class would that be? Huh? That's a very common one. But it allows us to version our knowledge graph as well, because as we already know in technical communication, it's very important that we also keep track of different versions of the domain model, but also of the instance data itself. Yeah? So this is basically the broad picture that we are providing right here. So let's look at least this in more detail, and the others I'm just going to explain briefly. But what you could already see, I've always attached these other sub-ontologies, such as the country or the property class, which nicely illustrates that our ontologies can be extended quite easily. And what we would suggest is that we always go for a modular ontology design. The modular approach that we already know when it comes to authoring, content and topic-based content management systems. We also suggest that we model our ontologies in smaller bits, that they can be extended, that they can be exchanged, such as IIRDS. We just plug it in, we just use it. And then we extend the IIRDS class or the ontology by a relation to another one, and then they can live independently in one way or the other. So this product hierarchy, which is the core of our approach here, basically says I do have a class product hierarchy, and then we have different subclasses. And you might agree with the labels that we've attached to these classes, or you might say, but we call it differently. Feel free to do so. It doesn't really matter. But what we encounter is that we very often talk about articles. If you look at your portfolio, do you have articles? Probably. Yeah. You might call them differently, but that's an item that you're actually selling. You have an article number, and you're trying to sell that. Or we could have products, or you have series. Others might have, they call it maybe a product family, or a product group, or a design, a specific technology. It really doesn't make a big difference, but we need some kind of an overall mechanism or a structure that allows us to group the products itself into specific variants or product families. And this is what we're trying to achieve with this, what we see on the left-hand side with these articles or products and series that are subclasses of the product hierarchy. So this is one way of organizing the portfolio in general. The second thing that we do see here is that we do not just look at the product itself, but that we also want to look at how the product is actually built, of which components a product consists of. So that's why we have another relation, a product, or the overall class product hierarchy has a component hierarchy, and in this component hierarchy we model the structure of a product. Of which components does it consist? Because that's also very important information when we look at the door and the oven. I need to know which oven it is, which we get from the product hierarchy. And we also get the information, what kind of a door am I looking at? And so I can attach a topic to a specific component. And this is what I basically need, and that's what we find out. If we don't do that, our technical information is more or less free-floating, and we cannot get a very good access to that information. So this is the product hierarchy at this point. What else do we have? Let's go into, for those who are more interested in product information management systems. It might not be only sufficient to say, oh, I do have a product family and I have my products and do have a structure of my products, but it might also be important that you have in your knowledge graph stored information about the properties. What technical values do we attribute to a specific component? And so we also developed an ontology that allows us to store properties about products or about individual components in our knowledge graph. Because sometimes we use the knowledge graph in order to create a product recommender. And for this kind of application, we need, of course, the properties that allow us to filter according to specific requirements, that it might be this or it might be that kind of product that we want to sell to our customers. Do we have anything else? Yes, I'm going to keep that short. We also do have the market segment, which when we also look at how to deliver information, let's say to a PIM system, then it might also be important to have a market segmentation. In which countries are we selling which kind of products? How do they differentiate? This might be also very important information. But this gives you a brief idea on how we try to extend our individual ontologies according to specific needs. And now just a brief look ahead. When you look at the product, we can say, okay, it has some kind of a hierarchical structure. It consists of certain components, and the components consist of parts. But then we might also say, oh, wow, but we might also have some kind of systems that are part of our product. We have maybe a electrical system or a pneumatic system. That might also be some kind of important information. And of course, these systems then realize specific functions, so we can add other classes, relate them by links to the already existing one. And this tells us then how we can basically broaden our knowledge base according to specific needs. And what I already mentioned in the beginning, this is something we didn't develop ourselves, but we just stole it from the provenance ontology.
No, that means it's usage.
We use it. We didn't steal it. We use it. We borrowed it and implemented that as a given standard on how we want to version our ontologies. Okay, so that's the part on the product ontology, and as we already introduced, we want to try to bring the knowledge graphs together with the language models, and this is what Max can explain much better than I can.
Yep.
Yeah.
Thank you. Okay, so now we have both. We have IRDS for the document information, and we have our product ontology to transport information that has a deeper structure about the products themselves. But how does this come together in a GenAI application that at the end should, for example, be a service assistant or a company-based chat that you want to use. So we have basically two pipelines that we need to build, and we should start with defining the knowledge model. We reuse parts of IRDS, we use the product ontology, but of course we add taxonomies. So we add, for example, the concrete product hierarchy at your company or at your customer's company. We add information about anything related to these products. For example, the component hierarchy. And by doing that, we create the graph. We do that either by transforming structured data, or it could also be, it starts with the unstructured data. Once we have the graph, we can store it in a graph DB for later consumption. Then there's the second pipeline, the language model pipeline, which starts almost always with unstructured content. So the first step is to extract that content and create so-called chunks. So you want to have something that is close to a topic, something that has just enough information to make sense, but does not overlap too much with other things. Once you have these chunks, of course, you want to classify them. You want to say, okay, this part of the manual, for example, is about product XY, and it is about exchanging like a certain component, for example. So this is the information that you want to have, and that as a classification on the document. And that is exactly where the two worlds come together the first time. We use the part of the graph that is mainly the taxonomies to do that. So if we have created a component hierarchy, if we have created a product hierarchy, we can, also using GenAI, let the AI classify the content based on the graph structures that we have. Once we have done that, that's called embedding. Probably many of you have heard that many times in the last weeks and months. So you know what it is, but you need to store that chunks in the vector DB to be able to do a similarity search later on, but you also want to keep the metadata that you have added to it during the classification in that DB. That is the extract and load part, but how does that come together once you query and retrieve the information? So there's a lot of stuff happening here. Maybe let's just keep to the main parts. So you ask a question, you want an answer. How do I exchange part XY? What is the rated speed of something, etc. But how do you get that answer? So first time the question is answered, you might want to rewrite the query into multiple ones or not. That is one thing. But you surely want to check that the query is routed to the correct information source that you want to use. In that example, we use the vector DB and the graph DB at the same time. So in the graph DB, we are talking about entities. We are talking about a certain product, I don't know, a customer record, or any entity that the question might be about. We want to extract that entity from the question and query the graph accordingly to retrieve the facts about that question. And at the same time, we use the embedding again, the embedding of the question this time, to compare it with the entries in the vector DB, and based on a similarity search, retrieve unstructured information that we have extracted previously. In the next step, we combine the two. So we combine the facts that we get from the graph and the chunks that we have retrieved from the vector DB, and we do a ranking and filtering. So it could be that, like from the question, we have determined that it is about a certain component. Then we want to make sure that we do not include parts of a manual, for example, that are not specifically about that component. That's the issue with the similarity search. If you have products that have variants, for example, a lot of your parts in the manual will more be the same. So they just talk about a different variant of the product, but you want to return, of course, the correct one and not the variant that the user is not talking about. So there's the ranking and filtering. And then, of course, the last step is generating the answer using all of that context that you have just retrieved and put together. And how that looks like in a concrete example we have here. This is a service assistant, a project that we have just finished, and it shows that exact thing which I just described. You asked a question, and at the first step, the question is analyzed, and the metadata that we extract and that we map to the taxonomy is also shown here already. And the same thing happens for the answers. So the question and the answer are mapped on the basis of their metadata. Yeah. If you want to try this out, you can come to our booth. We have a demo of this running. Actually, it's 3 demos. Might want to see how it behaves in a real-world scenario. And there's a little bit more. Yeah.
I think that's actually also your part.
Yeah, that's also
that's also your part.
No, there's more.
There's more.
From this take-home, we start a platform that helps building a knowledge hub. So everything that you have just heard, what you need to do, we do that many times in different projects. And we have built tools to assist with that. So if you're thinking about building a knowledge graph, then come to us, talk with us about it, and there's something for.
There is something, exactly. And there's still a couple more minutes to go, because we thought there might be, we talked about a lot of stuff. And maybe there's still some answers out there. So thanks, Max, for the presentation.
Thank you.
And if there's anything you would like to know about knowledge graphs, on how knowledge graphs interact with large language models, or about product ontologies, this is the time. Yes, go ahead.
Yeah, thanks very much for the presentation. It's very interesting. I just have a question about using basically the knowledge graph and the vector database in parallel. Did I understand correctly that you're deriving the metadata for the chunks that are stored in the vector database from the ontology? Is that right?
Yes, from the taxonomy, yeah. We use the taxonomy to classify the content, yes.
Is that done automatically?
Yeah.
So do you ask the LLM, hey, can classify it according to a certain schema?
Exactly. Yeah.
Second question, do you use LLM as a judge or anything like to verify the content that is retrieved from the vector database?
Yeah, and you can and you should do that. That's part of the re-ranking and evaluating the answer. But of course, it is still, it does not get rid of the original issue, is that you have like maybe false answers or false analysis of the language model. So you would still want to use another mean of checking the answer, and that is where we also look into the graph and say, okay, there's like the facts unaltered, and we can also compare it to the answer. But yeah, that works.
So thanks for the presentation, very interesting. One question, assume we have a chatbot implemented using a RAG pipeline. And this works quite nicely, but we have not yet used any knowledge graphs. So from your point of view or from your experience, what are the criteria that should be met that most likely a knowledge graph could further improve the answer of the chatbot?
Yeah, so the first thing you could do is create a taxonomy. So you have a controlled vocabulary that you can run the language model against, so use it for, it's called grounding, to try to move it more towards, the questions or the information that you want to like it to retrieve. And then the interesting part is, do you have any unstructured, any not unstructured content that you would like to add? For example, if you have technical information about a product, like properties of it, coming from an ERP system or a PIM system, or like you have it already in structured form, and you want to make sure that you do not extract just, for example, the technical data sheet from the manual, but you use like the original like information about that product, then that would be the next step, to add this in a structured manner into the graph, and then you can add that.
Okay, but I mean, the technical specifications are a good example. Now let's assume they are just imported into the documentation, and the RAG pipeline can read this out without any problems. So where would the value add of a knowledge graph be in this case?
Yeah, the question is if you can like make sure that the table in the manual, for example, has all of the, or is being identified as only that entity, only that property of that variant of the product. So usually those tables, they are really good. Like if you look at them, you might find the information you want, but if you use it as text and to generate an answer from, like it fails at the most like detailed level. There it fails usually.
Okay.
Maybe as an explanation, what we did, when the example that we actually have on the booth and that you saw is that you can ask, what is the maximum load of a specific part of the product? And if you don't specify the product itself, you get, if it's variant A, it's 10 kilos, it's variant B, it's 15, if it's C, it's 25. Yeah? And if you combine it with the metadata on which product am I looking at, then you can filter out the exact information, because otherwise the LLM wouldn't know that. Yeah? And this is one part. And the second part is also that if you also integrate the technical information or the TechCom topics into the knowledge graph, then you automatically could limit the search space. And then you just look in this part of the domain, and then you retrieve the answer from that part. Yeah.
Thank you.
And there's also something that you usually cannot answer just by querying with RAG. Is, for example, if you ask about, hey, do you have like the median whatever usage times of something, where you would need to start calculating, then of course it is something where you want to have a structured data source that you can actually query for that.
Yep, very interesting, thank you. Anything else? Everybody's already, yes, there we go. Not tired yet. Not yet.
It's a bit of an open question regarding a paper that was published recently by Mikael Ian Tosca, and he has similar thoughts to you about the absolute necessity for knowledge graphs, but instead of chunking the content, he basically uses the intrinsic structure of the content to create a knowledge graph of a content. So in your pipeline, the knowledge graph is being used just to attach metadata to the chunks, but in his approach, he's kind of connecting to knowledge graphs, you would say.
But that is where IRDS and topic-based documents really help. So if you have the structure and for, if you have a CCMS, for example, that gives you topic out of it with metadata, then you have that. You have the inner structure of the document, and that is actually also then part of the graph. And of course, you should always have that, but sometimes it's difficult to get the inner structure right there.
But it once again tells us that, I mean, the chunking is, and the analysis and the classification is done with the unstructured data, and which we do have a lot. We have a lot of legacy data, and we can still use this approach to get fairly good results. However, and maybe this is also some kind of a promising outlook for our community, the better the content and the more structured the content is, the better results we get. So that's something that we always emphasize. If you already do topic-based authoring, if you already assign metadata to your topics, then you will not do the automatic, or you do not have to do the automatic classification. But a lot of authors always ask, oh, why would I have to classify my topic? It's part of my document anyway. But it relates to the component. It's made for a specific audience. It also has maybe some activity types that you want to address. And if you do that in the creation process, the better your results are. That's quite obvious. Yeah.
Thank you.
Okay. We take one more.
I'm a technical writer at a software company, so I write software documentation. I think you were talking mainly about production products.
Yeah.
Is there a similarity or a usage, or
well, I just give this the question back. Is your software somehow structured?
Yeah, the software.
I hope so.
Yeah, I hope so too. I'm not
But it's not your responsibility, I know.
we have different applications.
Yeah.
Yeah.
There we go.
Yeah.
Different functions.
Sorry.
Different functions.
Yes.
Yeah.
Yes. Yes.
So basically, what we haven't done that yet. But I just came across this question in another project, but we haven't found the solution. But we know how to solve. No, we don't know yet, but we think we know how to solve it, because a software itself, as a software product, is made out of individual software pieces. You have functions, you have systems, and it breaks down into individual, basically the smallest part is the function. And then we can basically have the same structural breakdown of a piece of software. And this is what we could then use, very similar to the structural breakdown of our physical product. We structure a software, and then we attach software documentation modules to these functions, systems, or components, whatever it's called. Yeah. So this object orientation that we apply also for the module design, when we look at, let's say, an aircraft or a car or whatever, anything else, is also applied in software development. So we could, the classes might be labeled differently, and it's maybe a more complex structure, maybe. But I think the approach itself is still valid. Yeah. Okay.
Yep, 45.
One more minute. So thank you very much. Also for these interesting questions. I think it also helps us to think further of what we're trying to develop here. If you have any feedback on this kind of ontology, would like to discuss it with you. We already published a paper on that. So it's not a secret. We want to pursue it further. We want to get maybe also a crowd to stand up and say, yes, this is what we need. And if you say, how you forgot this or we would do it differently, we're happy to discuss it. Enjoy the conference. Thanks a lot.